Bright Tuty. Every student matters.
Now that we had learned so many things about matter, about mixtures and pure substances, on the basis of this, let us try and solve few questions. Now, the first question is, classify the following as chemical or physical changes. Now, what do you think cutting of tree is? It is simply change of the size and shape. So, it is a physical change. Melting of butter in a pan? Oh, definitely it is a physical change. Why? Because you are only changing the state of the substance. Rusting of Almirah? It is a chemical change. Why is it a chemical change? Because rusting of Almirah happens only due to chemical reaction between air and moisture. And we already know that rusting is a phenomena in which the iron reacts with oxygen and moisture to form iron oxide. So when an Almirah gets rusted, definitely it is not a physical change, it is a chemical change. Boiling of water to form steam? Yes, it is a physical change. Passing of electric current through water and the water breaking down into hydrogen and oxygen gases. This is a chemical change. Why? Because water molecule has been broken down into hydrogen and oxygen. So there has been complete change in the composition. The bond has been broken, water is now changed into hydrogen and oxygen, which is a new substance, and thus it is a chemical change. Next, dissolving common salt into water. So when we dissolve common salt in water, it is simply physical change because it is forming a solution, a homogeneous solution, mixture, and it is a physical change. There is no change in the composition. Making a fruit salad with raw fruits? Oh, I don't need to tell you, it is a physical change. Burning of paper and wood? I already explained you, it is a chemical change because a new substance is formed when you burn paper or wood. The next question is, try segregating the things around you as pure substances or mixtures. Now, what you do is, you try and identify different things around you and place them together. Then you group them according to whether they are mixtures or pure substances. Let us carry forward. Which separation technique will you apply for the separation of the following? If you have sodium chloride from its solution in water. Now remember, sodium chloride is forming homogeneous mixture. So definitely it will not be possible for you to separate it through filtration. So what would be the process? The process would be the difference in boiling point, and we do it by evaporation. When you evaporate the salt solution, the water will get evaporated, leaving behind the salt. Number B, ammonium chloride from a mixture containing sodium chloride and ammonium chloride. We already had done it. This is through sublimation. Because we know that ammonium chloride sublimes. When heated, it directly gets converted into the vapor state, whereas sodium chloride remains in the china dish. Number C, small pieces of metal in the engine oil of a car. Now, how would you do it? Yes, definitely. Either you can do through the process of filtration or by the magnetic separation method. In magnetic separation method, you will take a magnet, put it inside, you would see that all iron pieces will cling to it because it is a magnetic substance, and iron can be separated from engine oil. Next, different pigments from an extract of flower petal. How would you do it? See, it's flower petal, so there are colors involved. and we would do it through chromatography. Alright, butter from cow. Oh, we had already discussed it. This is through centrifugation. Why centrifugation? Because we know a colloid can be separated through centrifugation only. Oil from water. Please try and recollect. Did we do something with separating funnel? Yes, you will use a separating funnel. Why? Because both oil and water have different density. So, oil will float over water and form distinct layer which can be separated easily. Tea leaves from tea, what would you do it? I don't need to tell you at all. That can be done by sieving. You can use a siever or by the process of straining. You use a strainer to separate tea from the tea leaves. Iron pins from sand. Now, that is through magnetic separation. Why magnetic separation? Because iron is attracted towards a magnet. So, you can easily separate iron pins from the sand. Wheat grains from husk. Now, what do you need to understand? Wheat grains are heavier whereas husks are lighter. So, it will be separated by the process of winnowing. Though we did not discuss it in this chapter, but in the previous classes you have already learned that separation of substances, if they have variable weights, then you can do so by the process of winnowing, which the farmers normally do. Next, fine mud particles suspended in water. What would you do? You will rather let it decant and separate it through filtration method. So, these are some of the techniques that you would apply to separate the following mixtures. Next, write the 4 steps you would use for making tea. Use the solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So, these are some of the terms that you need to use. That means making of tea is a mixture. We know a cup of tea is a mixture. Now, let us start. Let us take water in a pan and start heating it. We add solute sugar to the solvent water so that sugar solution can be made. Once sugar dissolves to make a sugar solution, then what do? We add tea leaves to it. The color and the flavors of tea leaves are completely soluble in the sugar solution, whereas the tea leaf is not soluble in the sugar solution. Then we add milk to the solution and boil it further. After some time, we put it off and then using a strainer, we filter it. By filtering, we get tea leaves as the residue and the filtered tea as the filtrate. So, you see, by using these terms, we have already made a cup of tea. Next, explain the following giving examples. Now, water saturated solution? Exactly. When no more of the solute can be dissolved in the solvent, then we term it as saturated solution. What are pure substances? Pure substances are those when they are made up of same kind of particles. So, these are keywords that they are made up of same kind of particles. Next, what are colloids? They are heterogeneous mixtures. Okay, they are heterogeneous mixtures and they show Tyndall effect. Their size of the particles is within the range of 1 nanometer and 100 nanometer. So you can have all this explanation to define a colloid. Suspension. Again, suspension is also a heterogeneous mixture. Alright, it is a heterogeneous mixture. And the particles of the suspension is suspended in the bulk material, which can be easily distinguished and observable through our naked eyes. Okay, let us solve the next question. Classify each of the following as homogeneous or heterogeneous mixture. Now, what is homogeneous mixture? That is mixture in which the composition is uniformly distributed. Whereas heterogeneous mixture means where the components are non-uniformly distributed. Now, there are some mixtures which are given. Let us identify them. Now, what is soda water? Yes, it is a homogeneous mixture. Okay, it is a homogeneous mixture. Whereas wood is a heterogeneous mixture. Alright, air is a homogeneous mixture. Fine. Soil is a heterogeneous mixture. Similarly, vinegar is homogeneous mixture because it is uniformly distributed, and filtered tea is homogeneous mixture. So, in this case, we find that wood and soil are heterogeneous mixture, whereas soda water, air, vinegar and filtered tea are homogeneous mixture. Now, let's go to the next question. How would you confirm that a colorless liquid given to you is pure water? Now, which property would you identify to find out whether the colorless liquid is pure water or not? For that, we need to remember and recollect what is boiling point. We know that every liquid has got a fixed boiling point at which it starts boiling. And what is boiling? It is a bulk phenomena, whereby the entire particles which are present in the bulk starts boiling at the same time. And this happens only when a particular fixed temperature is reached. So, in case of water, what would happen that if you take that liquid in a beaker and then you start heating it. As you keep on heating, if you find that the liquid starts boiling at 100 degrees Celsius, so if you place a thermometer and you find that the thermometer shows a reading of 100 degrees Celsius, that means the liquid is pure water, because that is the boiling point of pure water. But in case it is less than 100 or greater than 100, then definitely it is not pure water. So, without tasting it, you can find out whether the liquid that is given to you is pure water or not. Only if it starts boiling at 100 degrees Celsius, because that is the boiling point of water. I hope this is clear. Now, let's go to the next one. Which of the following materials fall in the category of pure substance? Now, do you remember what are pure substances? Pure substances are those which are made up of same kind of particles. They can be either elements, that means made up of same kind of atoms, or compounds made up of two or more different kinds of atoms, but they are chemically bonded and behaves as one. So, let us start. Is ice pure? Ice is made up of water molecules. That means it is H2O. So, definitely it is a compound and this compound exists in the solid state. Thus, ice is a pure substance. Alright, next comes milk. Milk is a colloid and it is a mixture. Why mixture? Because it has fats, proteins, vitamins and other things mixed in the dispersing medium, water. So thus milk is not a pure substance. It's not a pure substance because it is a mixture. It is a colloid. Next, iron. Iron is a metal and definitely iron is a metal and it is also an element and thus it is a pure substance because in case of iron, if you keep on breaking it into smaller pieces, you would find that each of these pieces, each of these particles consist of the same kind of properties, both physical and chemical, and thus iron is a pure substance. What about hydrochloric acid? Hydrochloric acid has a chemical formula of HCl. Now, HCl means it has got hydrogen and it has got chlorine. And this is a compound. Because it is a compound, that means it is also pure. Calcium oxide, again a compound, and it is a pure substance. What about mercury? Mercury is an element. It is a metal that exists in the liquid state at the room temperature, and it is the only metal that exists in liquid state. So, because mercury is an element which is a pure substance. Next, brick. Now, brick is made up of sand, clay, all these things mixed together. They are baked and bricks are made. So, definitely because it is a mixture, so it is not a pure substance. What about wood? It is also a mixture. Whereas air is also a mixture and not a pure substance. Because we know pure substances are those which are either an element or a compound. So, air is not an element nor is it a compound. It is a mixture of gases. That's why air is not a pure substance. Fine. Now, let's go to the next question. Alright, the next question is identify the solutions among the following mixtures. Now, we know that solutions are homogeneous mixture. There are two types of mixture, homogeneous and heterogeneous. Homogeneous mixture have uniform composition and solution is one of them. So, solution is a homogeneous mixture where we find the components of the mixture are uniformly distributed. So, here there are 5 mixtures given to us and we need to identify which is a homogeneous mixture, that is which is a solution. Now, when it comes to soil, then soil is not a solution. It is not a solution because we know that it is a heterogeneous mixture, whereas seawater is a solution. Why? Because the components of the mixture are uniformly distributed. Air is also a homogeneous mixture and thus it is a solution. Alright. Soda water is also a solution because it is a homogeneous mixture, whereas coal, we find that it may have different components and that's why it is not a solution. So, which amongst them are solution? We find seawater, air and soda water are the 3 solutions amongst the given mixtures. Okay, the next one. Which of the following will show Tyndall effect? Now, what is Tyndall effect? Tyndall effect means scattering of light. Can you recollect the examples that I had given you? Suppose early in the morning somebody brooms the room. So there will be dust particles dancing all throughout the room. The small speck of sunlight that enters into the room would show the beam of light or would show the path of light. So this scattering of light by the dust particles is known as Tyndall effect. Similarly, we see that suspensions and colloids shows Tyndall effect. Do you remember why? Yes, because the size of the particles are quite large and they easily scatter the light, thereby showing the path of the light. Whereas in case of solutions, because the size of the particles are very small, so they do not show any Tyndall effect. So solutions show no Tyndall effect, whereas suspension and colloids show Tyndall effect. So on the basis of this understanding, let us try and solve this. Salt solution. Is salt solution a solution, suspension or colloid? So because salt solution is a solution, that means there will be no Tyndall effect. Alright, because it is a solution. The size of the particles are very minute and they will not be able to scatter the light at all. Next, milk. What is milk? Milk is a colloid. And because it is a colloid, we already see and we know that it shows Tyndall effect. So, milk will scatter light and shows Tyndall effect. What about copper sulfate solution? Copper sulfate is a salt that readily dissolves in water to form copper sulfate solution. Now, this solution is clear. And when you pass the light, there will be no scattering of light because it is a solution and thus no Tyndall effect. What about starch solution? Yes, starch is a colloid. Starch solution is a colloid and thus it will show Tyndall effect. So thus you see that solutions do not show Tyndall effect, where suspension and colloids readily shows Tyndall effect. Now let us do the next question. Classify the following into elements, compounds and mixtures. Now the moment before solving this problem, we need to understand what is element again. Recollect yourself. Elements are things that are made up of only one type of particles. Okay? That is, they are made up of same kind of atoms. What are compounds? Compounds are those which are made up of two or more different kinds of atoms. Whereas what are mixtures? Mixtures are those in which two or more different pure substances are mixed together. Okay? Without any definite proportion. Now taking all these understanding and knowledge into account, let us solve them. Now what is sodium? Sodium is an element because it is made up of only one type of atoms. What is soil? Soil is a mixture. Why? Because it consists of sand, there will be pebbles, they are going to be mud, humus, so on and so forth. What is sugar solution? Definitely sugar solution is also a mixture. Okay, because we have two different components, sugar and water. What is silver? Again, silver is an element because it is made up of only one type of particle atom, that is silver atom. Calcium carbonate. Calcium carbonate has a chemical formula of CaCO3. So you would see that there are three different types of elements that combines to form a compound. So thus it is a compound. Tin is also an element made up of only tin atom. Silicon is again an element. Alright. Coal is a mixture. Air is a mixture. Soap is a mixture. Methane is a compound. The chemical formula is CH4 and thus it is a compound. Yes, what is carbon dioxide? Carbon dioxide is a compound because it is made up of carbon and oxygen. So there are two different kinds of atoms that have made into a compound. Now what is a blood? Blood is also a mixture. Clear? So I hope you have understood how we did the classification. Which of the following are chemical changes? Now, do you recollect what is chemical change and physical change? Chemical changes are those in which a new substance is formed and it does not retain any of the previous identities or properties. Whereas physical changes are those where only the physical attributes or properties changes. There is no change in the chemical composition. So, taking all this knowledge into consideration, let us see whether these things are physical change or chemical change. So, which of the following are chemical changes? Growth of a plant. What do you think? Is it a chemical or a physical change? Because it is a permanent change, irreversible change, thus it is a chemical change. Because growth cannot be reversed. Rusting of iron. Now, when does rusting of iron takes place? When iron is left exposed to the atmosphere, in the presence of moisture and oxygen, it forms iron oxide. And this iron oxide, the layer of rust that we call, is a new substance which has no property of iron or water or of oxygen. So, thus it is a chemical change. Mixing of iron fillings and sand. Now, that's very simple. If you take some iron filling and sand and mix them together, there will be no chemical combination at all, and you can vary the composition. So, thus mixing of iron fillings and sand is basically a physical change and it is not a chemical change. What about cooking of food? After the food is already prepared, can you reverse it back? For instance, if your mother cooks your favorite dish, then what would happen? She takes raw things, she keeps it in a vessel, she cooks it, she uses spices, but once the food is ready, can you get back the original one? No, not at all, because there is a permanent change, and thus we call it as chemical change. Digestion of food. Now, in digestion of food, what happens when you take in the food, it reaches your stomach and then there are enzymes, they are digestive juices that acts on it and they break down the complex food into simpler substances. So, thus digestion of food is a chemical change. Not only the physical properties changes but also the chemical properties. What about freezing of water? Suppose you have a bowl of water and you place it in the freezer. What would happen? Definitely there will be a change of state of matter, that is the liquid will freeze into solid, and thus freezing of water is a physical change. What about burning of candle? Now, the wax in the presence of heat and presence of oxygen will start giving out heat and light. So, the wick takes in the wax vapor and in the presence of oxygen, it carries on the oxidation reaction, thereby giving heat and light. So, once the candle is burnt, you cannot get back the original one. Thus, burning of candle is a chemical change. Let's go to the next question. Pragya tested the solubility of 3 different substances at different temperatures and collected the data as given below. Results are given in the following table as grams of substance dissolved in 100 grams of water to form a saturated solution. So what did Pragya do? She had tested the solubility of 3 different substances, okay, at different temperatures and collected the data. So here the substances are given. What are the substances which has been dissolved at different temperature? Alright, now taking this into account, let us solve the problem. The first problem is what mass of potassium nitrate? Now what is potassium nitrate? this is potassium nitrate, would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin. So we need to find out that at 313 Kelvin, for 100 gram is given to be 62. So they want to find out that how much of potassium nitrate should be added in 50 gram. So the answer would be like, since 62 gram of potassium nitrate is required in 100 gram of water. So therefore 62 by 31. Okay. Therefore, in 50 gram, how much will be required? In 50 gram of water, it is going to be 62 divided by 2. Why 62 divided by 2? Because for 100 grams, if it is 62 grams of potassium nitrate, then in 50 gram, which is half of 100 gram, it is going to be half the amount of potassium nitrate that has been used up in 100 grams of water. So in 50 gram, we are going to make half of it, that is 62 divided by 2, which gives us 31 gram. That means you need to take 31 gram of potassium nitrate to make a saturated solution at 50 grams of water at 313 Kelvin. Okay. The next question. Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain. Now, the very first thing that we need to understand that the solubility increases with temperature. We know that solubility of any substance increases with temperature. Now, in this case, what is happening that Pragya made a saturated solution of potassium chloride in water at 353 Kelvin. Okay, so at 353 Kelvin, she made a saturated solution and then she cooled it at room temperature. So the moment she brings it down, as she cools it, what will happen? The crystals of potassium chloride would separate out on cooling. Why? Because the solubility of any substance increases with water, with the rise of temperature. Alright, next let us see number C. Find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? So here it is at 293 Kelvin. They are saying that find the solubility each salt at 293 Kelvin, and you have to say which substance or which salt has the highest solubility at this temperature. So let us look into the table. So at 293 Kelvin, you would see that potassium nitrate takes 32 grams, sodium chloride 36 grams. At the same temperature, potassium chloride requires 35 and ammonium chloride 37. That means among these four, 37 gram of ammonium chloride is required to make a saturated solution in 100 grams of water. So what would be the answer? The solubility of, what did we find? That the solubility of ammonium chloride, which is 37. So the solubility of ammonium chloride, which is given to be 37 gram at 293, is the highest. Alright, so ammonium chloride has the highest solubility at 293 Kelvin. Okay, number D. What is the effect of change of temperature on solubility of a salt? Yes, what we had already discussed, that the solubility of a salt would increase with the increase in temperature. And you know why it increases with the increase of temperature? Because more the temperature, more would be the space available between the particles, and thus more salt can be added to it.